Hello everyone, this is Shiva. This type of arrangement. So what they've given is two pith balls carrying equal charges are separated by R. If the strings are rigidly clamped at half of the height, right? So initially they've given this total height as Y. So at half of it, right, Y by 2, they clamped this whole thing like this, right? So this whole thing came like this, right? Now find the equilibrium separation between the balls. That's what they asked. Okay, so let's say initial separation, let's say this angle is some theta, right? So from equilibrium this will also be theta, right? So Fc mg t theta t cos theta t sin theta, right? T cos theta is equals to mg, t sin theta is equals to Coulombic force of repulsion. So tan theta is equals to Fc over mg, right? Fc is k q square by r square, right? They've said equal charges, right? So I've taken that as q, right? Is equals to, sorry, by the mg is there, right? Mg is equals to tan theta. So from here tan theta I can write as opposite one. So let's say this separation is r by 2, this separation is r by 2, right? So r by 2, opposite and adjacent is y, right? So from here kq square 2kq square y is equals to r cube mg, right? So this is the one relation we get. So from here we can see, for here there is no charge leak or anything like that, right? So q is constant, k is constant, 2 is constant, m is constant, right? There is no mention of mass being changed. G is also constant, so I can write y is proportional to r cube, right? Or r cube is proportional to y, so r is proportional to y power 1 by 3, right? So here initially separation is r, now here it is r dash. Initial this distance, right? This vertical is y, now this is y by 2, so r1 by r2, taking it as y1 by y2 whole power 1 by 3. So r1 is r, equilibrium separation in first case, equilibrium separation in second case, r dash, right? That we want, right? New equilibrium separation, r dash is equals to y1 is y, y2 is y by 2 whole power, sorry, whole power 1 by 3, right? So y gone, so r dash is equals to 2 power 1 by 3 comes this side, so r by 2 power 1 by 3. So this will be the new equilibrium separation between the pith balls, right? If they are clamped at half of the distance, right? So yeah, the main thing is components, right? And this relation. Another variation we've seen that when angle is small, not here by the way, right? I'm just mentioning, not, this is not in this case. If angle is small, then tan theta we can equate to sin theta, right? In that case we will have another this separation, right? I mean we can relate this and L, length of the string, but here we need this separation, so that's why I have taken tan theta as it is, right? So I hope you got the concept here. So thank you very much. I'll see you in the next model.